Combination of capacitors. Hi. In this video, we will find out how we can combine different capacitors, and how we find the combined capacitance for it. Let's start. Capacitors can be connected in either series or parallel. If you have not watched the series parallel video, make sure to watch that after this. Before we begin, there are two key concepts that we need to keep in mind. Number 1. In a series circuit, voltage is divided into the circuit components, and this individual voltage is equal to the voltage of the source. Number 2. In a parallel circuit, the charge is divided into the circuit components, and this individual charge is equal to the charge of the source. Let's now dive into our main concept. Let's say 3 capacitors of capacitance C are connected in the series circuit to a voltage source V. Each capacitance has the voltage V1, V2, and V3 respectively. We know that for capacitors, V is equal to Q by C. So, V1 is equal to Q by C1. V2 is equal to Q by C2. V3 is equal to Q by C3. Since charge is constant in a series circuit, therefore Q will be the same for each capacitor. For a series circuit, V1 plus V2 plus V3 is equal to V, as discussed in the beginning of the video. V is equal to V1 plus V2 plus V3. Putting the value of V, V1, V2, and V3, we get Q by C is equal to Q by C1 plus Q by C2 plus Q by C3. Q cancels each other, and we get 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3, where C is the equivalent capacitance of the capacitors combined in the circuit. Let's connect the same 3 capacitors in a parallel circuit. In a parallel circuit, charge Q will be divided among the individual capacitors. Let's say C1 is Q1, C2 is charge Q2, and C3 is charge Q3. And the voltage source is charge Q. Q is equal to Q1 plus Q2 plus Q3, as discussed in earlier videos. Putting the values of Q, Q1, Q2, and Q3, we get C into V is equal to C1V plus C2V plus C3V. Dividing each side by V, we get C is equal to C1 plus C2 plus C3. Where C is the combined capacitance of all the individual capacitors, when connected in the parallel circuit. This is the result we get when we combine capacitors in series and parallel. This is it for today's video. Let us know in the comments section which topic you want to see next. Before leaving, check the exclusive offers, link in the description below. And do not forget to hit the like and subscribe button. To find out more on the subject, continue watching the next video.